In the last video, I briefly mentioned how to understand the equivalence principle from Einstein's theory, namely space-time background is curved. However, do we really understand it? Like, curving the space-time is counterintuitive, and it really requires you to be Albert Einstein to come up with it. For an average person with average IQ like I am, I could have never thought about it. So for people like us, is there a better vanilla way to understand the equivalence principle? It turns out to be yes, and the argument was presented by one of the greatest physicists in the modern era of theoretical physics, Steven Weinberg. In 1960s, Steven Weinberg computed the soft graviton emission rate from a general scattering process, where graviton is the quantum particle associated to gravity, and the general scattering process could involve all types of external states, like protons, gluons. And Weinberg showed that the soft factor for this soft graviton emission rate does not depend on the external particle. It's completely fixed by symmetries and polarity, which is related to causality. By demanding that the S matrix, or the scattering process, properly transform under Lorentz symmetry, Weinberg showed the only way to conserve energy and momentum is to let all the couplings of soft graviton to the external particles to be the same. And this is really the statement of equivalence principle, where gravity minimally coupled to all the particles in the spectrum the same way. In this case, the equivalence principle is merely a consequence of fundamental properties of quantum field theory. We don't need the curving space-time background shenanigans. So for some radical quantum field theorists, including me, it's allegedly the first time that human being has ever understood the equivalence principle.